How would you feel if told that a computer could be in multiple states at the same time, processing information faster than ever before? Welcome to the fascinating world of quantum computing, an emerging technology that promises to revolutionize our digital lives. Unlike our traditional computers that use bits as their smallest unit of information, quantum computers use qubits. Here's where it gets interesting. A classical bit can be either a 0 or a 1, but a qubit, thanks to the quirky laws of quantum mechanics, can be both a 0 and a 1 at the same time. This allows quantum computers to process information in ways that classical computers simply can't match. Imagine a machine that can solve complex problems at speeds that make today's fastest supercomputers look like snails. Yes, you heard right. A quantum computer can be both on and off, at the same time. Confused? Don't worry, you are not alone. Ever heard of Schrödinger's cat? The idea that a cat in a box could be both alive and dead at the same time until observed? That's quantum superposition in a nutshell. Now let's delve deeper into this thought experiment by Austrian physicist Erwin Schrödinger. Imagine a cat placed in a steel box along with a radioactive substance. The substance might decay, and, if it does, it will release a poison that kills the cat. Now, until we open the box, we can't know if the cat is alive or dead. According to quantum mechanics, the cat is both alive and dead until we open the box to observe. This is known as superposition, the ability of a particle to be in multiple states at once. Now think of this in terms of quantum computing. Instead of bits, which in classical computing can be either a 0 or a 1, quantum computing uses quantum bits or qubits. A qubit, akin to Schrödinger's cat, can be both 0 and 1 at the same time, thanks to superposition. This is where the quantum world starts to differ drastically from our everyday experiences. You see, a classical bit can store an enormous amount of information, but it can only be a 0 or a 1 at any given moment. A qubit, on the other hand, due to superposition, can exist in both states simultaneously. This means it can process a lot more information and do it faster than classical bits. But there's a catch. Just like when we open the box to check on Schrödinger's cat, the moment we measure a qubit, it chooses to be either 0 or 1. It's as if by observing, we force it to decide. This is one of the fundamental principles of quantum mechanics, and it's at the heart of how quantum computing works. So just like Schrödinger's cat, a qubit remains in a state of alive and dead, or 0 and 1, until we decide to take a look. Now imagine if two particles could be connected in such a way that the state of one directly affects the state of the other, no matter the distance. Sounds like science fiction, right? Yet this is a reality in the quantum world. Welcome to the intriguing concept of quantum entanglement. This is where pairs of qubits, or quantum bits, become so entwined that the condition of one instantly influences the other. It's a bit like identical twins feeling each other's emotions from miles apart, but in the realm of subatomic particles. In the quantum computing world, this phenomenon is not just an interesting quirk, it's a powerful tool. Quantum entanglement allows us to perform complex calculations at speeds that would make a supercomputer blush. It's the secret sauce that gives quantum computers their unparalleled processing power. Imagine solving problems in seconds that would take conventional computers millions of years. That's the promise of quantum entanglement in computing. So, with quantum entanglement, we're not just bending the rules of traditional computing, we're rewriting them. So what does a future with quantum computing look like? Imagine a world where we can solve complex mathematical problems in the blink of an eye, or a future where cybersecurity is revolutionized, making data breaches a thing of the past. That's the promise of quantum computing. It's a field that's still in its infancy, yet filled with vast and largely unexplored potential. Quantum computing could usher in a new era of scientific discovery, helping us unlock the secrets of the universe, from the smallest particles to the vastness of space. It could transform industries from healthcare, where it could lead to breakthroughs in drug discovery and genetic research, to finance, where it could optimize trading algorithms and risk assessment. But remember, we're just at the beginning of this exciting journey. The full potential of quantum computing is still to be discovered. And as we continue to explore and learn, one thing is clear. In the world of quantum computing, the future is not just bright, it's dazzling. And we are just at the beginning of this fascinating journey.